Hey you guys, this is Professor Vitt. Welcome to Chapter 7 on Perceptual Error and Trickery. Um, let's start this little sucker out with a little optical illusion. We're going to do two of them today. I want you to look at these two green circles and notice that the one here on the left looks a little bit smaller than the one here on the right. Now some careful examination will show you that these are actually both the same size circle, but when your brain sees it in the context of these other big circles or small circles, it kind of varies the size relative to the context in which the circle is realized. So what? Well, it means that you are not actually as good at perceiving reality as you think you are. Your brain really constructs a model of reality. It represents reality. And when it does that, sometimes it cuts corners for speed purposes. And by and large, there's no problem there. But sometimes there is, and you notice that even though I explain this illusion, and I say this one looks a little bit bigger and this one looks a little bit smaller, they're really the same size, the illusion doesn't go away when I tell you it's an illusion. The same thing happens in cognition, right? Look at this example. I have a series of these guys here. Now, when I first saw this, even though I was looking for this specific illusion, I genuinely thought, oh no, they did a little trick here and they made this one a little more teensy than this guy just to really bump it up. So I took out a tape measure and I actually measured these guys. They're all the same height. But because of what's going on with perspective and what those lines are doing, your brain sort of changes the way that they look. And the same thing happens with beliefs. Your beliefs are closely tied to how you perceive the world. And sometimes functions of perception are also found sort of mimicked with regard to how our beliefs function. And so even though I'll tell you that a belief is incorrect, or someone will tell you a belief is incorrect, you're not likely to believe it. In fact, just in the same way that you still think this guy's probably a little bit smaller than this guy, if I tell you something and you already believe it, right? So paranormal phenomena or something, it's going to be very difficult to get your brain to change the way that it fires, just because it has this tendency to behave this way. So as just sort of an overview, we're jumping ahead a little bit there to confirmation bias, but we're going to cover three things in this lecture. Most of our work is going to be here on the second item, confirmation bias. So let's just jump right in. Okay, first up, the Barnum effect. The Barnum effect is named after P.T. Barnum. He was a circus millionaire, sort of ran P.T. Barnum Circus, Barnum and Bailey Circus. Let me give you an example of the Barnum effect. And just take a second, you might pause right now and read these statements. And determine whether or not they accurately describe you. Now, I'm cheating a little bit here when I tell you that you may not think these accurately describe you, but if I gave these statements to you in a controlled setting, and I said, perhaps I made a cursory attempt at collecting some information from you, maybe your birth date or something like that, or a simple questionnaire involving your favorite colors and some other things. And then I gave you back a report that looked like this and had your name on it. I said, okay, I have analyzed your personality. You will in fact think that these are highly accurate. In fact, people do. They rate these as very, very impressively accurate. Disciplined and self-controlled outside, you tend to be worrisome and insecure inside. Well, that can accurately describe me. It can describe a number of people. But we have a tendency to think when these statements are presented that they are somehow uniquely correct with regard to us, and they're very specific. Now, if someone's told ahead of time about the Barnum effect, this stuff doesn't work. But if you're not, then you're going to think that these are remarkably accurate statements. This happens a lot in different paranormal contexts. Sometimes it has to do with astrology. People will be given an astrological reading, and a series of these statements will be peppered in with the reading, and people will say, my gosh, that really, really seemed accurate. It's not that these people are gullible or anything like that. It's just a function of our brain that we're going to think this way. It has to do with the transparency illusion here, that we overestimate how much our internal states and characteristics are obvious to others. How would this be tested? Well, I'd pay attention to the red text right there. If you're looking on a test for an explanation of what the Barnum effect is, that red text would be pretty darn close. Okay, confirmation bias. This comes up when you deal with certain psychic readings. People will present a general statement, and they'll feel that someone will present a general statement, and the person who's getting the reading feels that it's very specific. This can also come up with astrological horoscopes. You may read a horoscope and say, gosh, that really, really describes me. It says I'm an independent thinker and I do not accept other statements without satisfactory proof. Well, that's great. But that, in fact, most people feel that would describe them. Let's move on to confirmation bias. And picture here is of an individual with a blindfold across their face. And that's a great way to think of confirmation bias. It's really, really, really difficult to get around, but the first step is being made aware of it. And if I make you aware of confirmation bias, you're going to be more likely to see it in yourself and make some attempt to correct it. So let's talk about what the heck it is. In simple, plain English, confirmation bias is looking for and noticing what confirms your beliefs, but ignoring and failing to look at or undervaluing what contradicts your beliefs. In other words, you count the hits and you forget the misses. The book has a great little section on confirmation bias, and I encourage you guys to look at it for purposes of the exam. I'm going to give you a couple examples of confirmation bias, courtesy here of the Emperor, in a meme. Okay, example number one of confirmation bias has got to be perhaps the most famous example of all time, and that's the moon and crime. People tend to think that crime goes up on a full moon. This is a student who worked in the emergency room, and years ago I was giving this lecture, and she immediately raised her hand and said, I work in an emergency room, and this is actually true. So people were interested in this. They want to know, is this possible? Does this actually occur? And so a number of studies were done. Here's a good link to a summary of those studies. But it turns out, no, crime doesn't go up on a full moon. And statistically, there's really no realizable difference between a full moon and any other night for an emergency room. They're all pretty much the same. Now, why would someone think this? Stop and realize that people working in emergency rooms are doctors and nurses. They are highly analytic thinkers. They've spent years and years and years learning all sorts of facts and dynamics of the body and so forth. And you have to have a certain amount of brain matter to do that. So people who think that there's a crime on a full moon, it's not that they're not intelligent people. And in fact, in some cases, they're incredibly intelligent. The problem comes in how they notice stuff. When it's a crazy night in the emergency room, they'll say something like, oh my gosh, this was a crazy night. And somebody says, well, yeah, it was a full moon. And they say, well, there you go. And everybody sort of remembers it. But when it comes time for, say they have another crazy night a week later or something, and somebody says, oh, this was a crazy night. Was it a full moon? And somebody says, nope. And then suddenly that just sort of, that instance of a crazy night that was not a full moon is not as vivid as the first one. So there's a little bit of availability error here packed in. But the idea is that on a normal crazy night, nobody notices that. They just say it was a crazy night. Imagine a case where it's a full moon and it's a totally normal night. Well, no one is likely to mention anything at that point, and so it won't factor into whether or not they think crime rates go up during a full moon. So, first example, the thought that a full moon increases crime rates. Statistically, there's no evidence to show that that's true, but the reason why people think that is confirmation bias. They remember the hits. They remember a night where they see, for example, a slew of gunshot wounds on a full moon, and then they forget those nights that are not full moons that are equally hazardous, right? So they count the hits and they forget the misses. Okay, example number 2. These are WASON problems. Heard it said both ways. They're a little technical, but the general idea is the same. We're going to be counting hits and forgetting misses. So let's suppose that I give you a rule and I give you 4 cards. And I say, if A is on one side of a car, then there's going to be a 3 on the other. And what I want you to do is to flip over the cards to determine whether or not this hypothesis is true. So I want you to determine the truthfulness of this claim. If A is on one side of a card, then there is a 3 on the other. And you ask yourself, what cards are you going to flip? Well, most people say immediately, well, I'll flip the A and I'll flip the 3, right? If an A is on one side, then there should be a 3 on the other. And if I flip the 3 card, there should be an A on the other side. But this is a little bit of a problem. You've actually skipped one. Obviously, you want to turn over the A card, right? If there was an A on one side of the card, then there should be a 3 on the other. So if we flip over the A and there's a 4, it's going to be wrong. Okay. Now, if we flip over the 3 card and there's a B, that doesn't help us much because one fucking thing. The one fucking point at which I have to do this. Okay, so we're going to go through some WASON problems. These are technical problems, but they're just demonstrating confirmation bias, which is we count the hits and we forget the misses. Okay, so we're going to look at another example involving confirmation bias. This one's a little more technical, so I'll try to walk through it. If it doesn't ring true, don't worry about it, but you need to see it in this context. It's part of the literature. Suppose I give you 4 cards, and they're labeled just like you see them here, and I say, here's a rule. And I want you to figure out whether this rule is true. If there's an A on one side of a card, then there will be a 3 on the other side of the card. So I want you to tell me whether or not this is correct and ask you which cards you would turn over. So if there's an A on one side of a card, then there's a 3 on the other. So look at the 4 cards and determine which cards you would pull over, you'd flip over. Okay, most people say A and 3, right? So let's walk through it. If A is on one side of a card, then there's a 3 on the other. So if I take the A card and I flip it over and there's a 3 over there, good, I have confirmed the hypothesis. Importantly, if I flip it over and there's a 4 on the other side, then I've shown that the rule is false and you're done. But suppose I flip it over and there's a 3. I've confirmed the rule. Now I wouldn't have any need to flip over the D card, right? Because it's not even mentioned in the rule. But a lot of people want to say, well, gosh, I'm going to flip over the 3 card as well. The problem is the 3 card doesn't really help you. The most that the 3 card can do is confirm your hypothesis. It won't disconfirm it. And this is what I mean. Think about this for a second. If I flip over the 3 and there's an A, then that's good. The rule is correct. But if I flip over the 3 and there's a B under there, it doesn't mean that the rule is wrong. It just means that there's a B on one side and a 3 on the other. If you really want to test this hypothesis, you need to flip over the 7. Why do you have to do this? Well, because there may be an A on the other side of that card. And if there is, then this rule is wrong. So it's a little technical, but it should be straightforward. Most people pick A and 3, but you also need to flip over that 7. Picking 7 will disconfirm our beliefs, but we naturally want to confirm our beliefs. We want them to be true. We don't normally like disconfirming beliefs. Let me give you the same example in a different context, and it'll be crystal clear what's going on. Watch this. Suppose you are a bouncer, and I show you pictures of people, and they're drinking or they're not drinking. So one picture is someone drinking a beer. Another picture is someone drinking soda. Another picture is someone who's clearly over 21. And then the other picture, this last one, is of someone who's 17 years old, and they're drinking something, but you don't know what they're drinking, okay? So this is the rule I want you to verify. If a person is drinking beer, then the person must be over 21. You get it? So if I want to confirm that beer drinkers are 21, bouncers do this all the time, they would ask the beer drinker, right? How old are you? So just like flipping the card over. You flip over the card, right? And you would want to check the person drinking beer for their age, right? So suppose I turn it over, they're drinking beer and they're 24. Okay, that's fine. Now, would I need to ask a person drinking soda how old they are in order to determine whether or not this rule is true, right? Or whether or not people are following this rule? No, because this rule has to do with drinking beer, not soda. So this card doesn't help us at all. Now, if I see someone who's over 21, clearly over 21, perhaps they have gray hair, just by their visual appearance, you can tell that they're over 21. You could turn it over, right, or ask them their age, and then they would tell you, yes, I am, or I'm not drinking beer. But if they're drinking beer, it's fine because they're over 21, right? So you would again confirm this rule by turning over this card or asking someone who's clearly over 21 years old what they're drinking, right? Now, if you see a 17-year-old who is drinking, you are going to want to ask them what they're drinking. Are they drinking beer or soda? You'd need to do that in order to enforce this rule. So the way to think about this is just you are a bouncer, and there's someone drinking beer, there's someone drinking soda, there's someone over 21 who's drinking something, you don't know what it is, and there's someone who's 17 years old and they're drinking something, you don't know what it is. If you're a bouncer, who do you ask, what they're drinking? Well, the beer drinker, you can certainly ask them, and you would. They're drinking alcohol. The soda drinker, you don't care about. The person who's over 21, they can confirm the rule, right? But the 17-year-old is the person you really want to know about, right? Because they're not old enough. Now, this example should be obvious to you. If you're a bouncer and these are people, who are you going to ask what they're drinking? You're going to ask the 17-year-old. I know this is hard to believe, but this is exactly the same problem that I've just presented to you. It's just in a different context. This is formally identical. This is important and this is interesting because what it tells us, and what WASON has kind of shown, is that we can do better or worse on reasoning depending on the context. And what it looks like, and this is one of the many theories that have been advanced concerning why this happens, what it looks like is we're really good at finding people who cheat. And this is important if you have a social animal like people, because we want to make sure that resources get distributed, right? So this is a reason, this is just a funny little result. It illustrates confirmation bias. It also illustrates that we're better in certain contexts at reasoning than we would otherwise think. Okay, example number 3, Mary Toft, 1726, gotta be the all-time classic confirmation biased example. Mary Toft faked a birth. She faked the birth of a rabbit. And yes, there's a rabbit right there in her lap. Hilarious. She actually fooled the king's surgeon into thinking that she gave birth to a rabbit. Now, I know you're thinking, well, this is 1726. I mean, what stage was medical science in? I assure you, there was not a doctor around before Mary Toft who thought that a human would give birth to a rabbit. I mean, as long as people had lived, they'd only give birth to other people. So this was considered very unusual, and it was a remarkable claim. But she was able to convince the king's surgeon that she was correct. Historically, people wondered how this could have happened, and someone finally did figure this out. So this is a contemporaneous drawing of Mary Toft faking her labor pains, and these are all individuals, by the way, identified by number. You can search the image online by number. But let me explain to you how she fooled all these folks into thinking this. Okay, so remember Mary Toft said that she gave birth to a rabbit, and the way that she did this was, so she essentially feigned labor and birth. She did in fact give labor to rabbit parts, in addition to another rabbit that she had, I think, alive at the time. Okay, how did this happen? Mary Toft didn't know about this, but her doctors did. Doctors used to have this, medical science used to have this theory called the doctrine of maternal impressions. And the way it works was, people would be born and they would have a birth defect, or they would be blind, or they would be deaf. And doctors just didn't know why that would be. They didn't understand yet everything that we know about genetics and the nature of congenital diseases and the effect of the environment on the fetus. They just didn't understand those things as well as we do now. So what they thought was, gosh, if a mother gives birth to a baby and the baby is deformed, it must be because the mother was attacked during her pregnancy. Likewise, if a child is born deaf, it must be because the mother heard an extraordinarily loud sound and that somehow imprinted itself upon the fetus. This was a good theory in a sense because it did explain a lot for these doctors. For instance, it explained why people were born looking the way that they did. It must be something that the mother did while she was incubating the baby, while she was giving this child life. And what Mary Toft did was she told doctors that during her pregnancy, she ate a lot of rabbit. She loved it and she craved it nonstop. She also said that she spent hours in the garden looking for rabbits. She loved them, she went looking for them, and so forth. They were a huge part of her life throughout her pregnancy. So what doctors determined was that somehow, in the same way that a mother who experiences a loud sound might give birth to a deaf child, so they thought, you might have someone who's somehow bombarded by all this rabbit stimulus, and what they do is they've actually changed their human child into a rabbit. And that was why they thought she did this, because it confirmed a theory that they already thought was true. And so they were more likely to believe it because it confirmed their beliefs rather than disconfirm them. Mary Toft was put on trial. I think she was put in jail for fraud. That's my recollection, but I could be dead wrong. Okay, so the book gives us some good reasons for the Barnum effect and confirmation bias. We'll kind of breeze past some of those. And now we're going to just briefly talk about everyday illusions. There are 3 of them here: periodola, apophenia, and perceptual constancy. Periodola is this idea that you can see a form that's very recognizable and familiar to you in an otherwise ambiguous shape or pattern. Apophenia is a very similar thing, but you're not looking at pictures, you're looking at facts. So here's an example of some periodola. Up here in the upper left-hand corner, you see there's a little picture. This was taken by the Viking orbiter. It went around Mars, I think in 1974, and took about 100,000 pictures of the surface of the planet Mars. When a NASA technician was looking through the data that was coming back, he saw this picture and wrote face and then put it in a pile, and it was never released to the public. Well, years later it came out to the public, and they thought, oh, here's this proof of an alien artifact on Mars, and yet, a monument, and yet NASA has brushed it under the rug. Well, it turns out this is a play of light and shadow. This is actually not, it looks nothing like a face, but we have a tendency to recognize faces in things that don't look anything like a face. So I give you an example here to this rock that looks like a human face. You can't help but see it. Of course, this is a natural formation. There's no carving going on here, but it looks like it. And then to push this point to total absurdity, we've got a sink here that looks like a face. And just in the same way that when you see that face, it persists, when you have a belief, even if you are shown that belief is incorrect, you are not likely to accept that revision. Instead, you will discount that evidence, or you would disregard it and keep your original belief. It's just the way that our brain works. And so it makes it really, really difficult to change somebody's mind on virtually anything. As a critical thinker, though, you want to be aware of this, that when you are presented with evidence that runs contrary to a belief you already hold, whether that has to do with psychic abilities or politics, you want to be very, very sure that you are not jumping to conclusions. Okay, here is some fun example of not necessarily Periodala, but very similar to it. It probably is. These are just shapes that people have seen culturally on the moon. So here you have man on the moon, and I think this is woman on the moon, and this is a rabbit. These pictures are available also in the book. Okay, so that brings us to the end of perception. It should be a fairly straightforward exam for Chapter 7. If you guys do have any questions or comments, please feel free to email me, and I apologize, there is no end slide on that one, so slipping a little bit. Okay, thank you much. Email me if you have any questions. rvitt@lbcc.edu.